Hello, and welcome to the F5 Visibility Solution in partnership with Splunk.
What are we going to talk about today?
We're going to start off by giving an overview of the solution. Then we'll go ahead and install it into our enterprise. We also have some very interested Big IP administrators and application owners that are interested to see what this visibility will provide them. The solution works as far back as Big IP 11.4. It utilizes Splunk's HTTP event collector to receive messages from the Big IP, which was available in Splunk version 6.3. The solution also works with Splunk Cloud. The F5 Analytics IAP is used to collect a variety of different data sources from each Big IP. In combination with the application mappings, this IAP is installed on each Big IP to send data to Splunk or Splunk Cloud instances. Application mappings enable the solution to visualize your environment. This is broken down into tenants and apps. Tenants are a collection of applications based on your configuration. This can be a collection of different applications per customer, i.e. customer X, customer Y, or a collection of applications based on environment, production, development. Any combinations of tenant mapping can be done. RBAC can be tied to a per tenant basis, allowing access to only their applications. Applications are a collection of virtual servers and wide IPs. These mappings are designed to align to the naming conventions and standards you have throughout your enterprise. Don't worry if you have more than one of them. Both tenants and apps are mapped within the F5 Analytics IAP deployed on each Big IP. The bottom section of the IAP allows for regex pattern matches to be configured for each one of the different business rules that you might have. An export option is available on the IAP. This allows the same application mapping to be utilized across the entire enterprise by simply importing the regex pattern match. Now that you know a little bit more about the solution, let's go ahead and install the F5 Analytics IAP on the Big IP infrastructure and install the F5 app on the Splunk environment. To configure the Splunk server, we'll start by turning on the HTTP event collector. We'll do this by going to the Settings Data Input section of the Splunk interface. Within the screen, we'll see a list of different data input types. We'll go ahead and select the HTTP event collector type. If this is the first time configuring HTTP event collector, we'll need to turn it on from a global settings perspective. Within the global settings section, we can turn on HTTP event collector. Here we can also set up some defaults from a global perspective. Note by default HTTPS is configured and our default port is 8088. Once HTTP event collector is enabled from a global settings perspective, we'll go ahead and set up a new token for the F5 Big IPs. One token can be used for all Big IPs. We'll create a new index for F5 data feeds. We'll call this index F5-default and click Save. Once the index has been created, we'll go ahead and ensure that it is the default index for this token. We'll click Next and Submit. This token value is the value that will be used within the IAP configuration on the Big IP side. We'll go ahead and install the new F5 Analytics app. This can be installed by downloading it from Splunk Base or by utilizing the Interactive More Apps section of the Splunk interface. Go ahead and search for F5 Networks. You can select the new F5 Analytics app. On the F5 side of the solution, we'll go ahead and install the F5 Analytics IAP. This IAP needs to be deployed to each HA pair or standalone unit. In an HA pair, this only needs to be deployed to the active member and synchronized. We'll start by going to the IAP's templates section. We'll import the IAP. And select Upload. Once the IAP has been uploaded, we'll go ahead and deploy it. This should be done only once on the common partition. We'll go and select the template that we imported. You'll need to input a facility name. This is commonly the location of the Big IP. This name does support case and spaces. In this case, this Big IP is located in SFO. The default tenant allows you to specify a standard tenant across all the applications that this Big IP hosts. In the case of a single tenant Big IP, commonly the default tenant would be configured here versus mapping it within the application mapping section. In my case, the tenant is company.com. The alternative device group section allows you to specify and override the default device group name. Commonly, sync failover is used for the device group if setting up the device group using the wizard. This field allows you to override that default so that it shows up properly in the Splunk UI. We'll go ahead and specify the IP address of the Splunk server, the port that it's configured on, and specify the token that we created earlier. The iApp does support the ability to send data via proxies. We'll go ahead and specify the iHealth username and password to send data to iHealth and pull data from iHealth into Splunk. This can be set up on a daily, weekly, or monthly rate. Now within the application mapping section, we can configure the appropriate mappings to map our virtual servers and wide IPs to the appropriate application and tenants. You can see we can specify the app and tenant name within the type, and we can map this information from a variety of sources, such as virtual name, wide IP name, partition, iApp name, etc. My naming convention is fairly simple. It is the application name dash the facility it's in dash the port. I'm also going to be mapping my wide IP names, which is simply the fully qualified name as the app name. The actions that I have here are to use mapping, or I can use a direct mapping action. This is further outlined within the solution deployment guide. Once completed, I'll hit finished and allow the two devices to synchronize. In an HA pair, it is common to have to sync twice, with the secondary member indicating that it has more recent changes. Allow your primary active unit to synchronize over the secondary unit if this does occur. Now that we've installed the F5 Splunk solution, we can go to the home page of the F5 app in Splunk. Here we have a critical dashboard showing key alerts within the enterprise. We can see a list of non-responding hosts, expiring SSL certificates, unhealthy devices and applications, along with the health score index calculated across the device cluster and the application, as well as recent virtual and pool changes indicating outages of these expected hosts and pool members to be online. We have an environment overview based on facility and tenants. Here we can see we have a PME lab facility in which we have a low score of 40 for one or more of the devices within it. We can click and drill down into a list of devices for that facility. We can see we have several big IPs within this facility that have a low health score. Let's go ahead and look at this 1151 device service cluster. At a quick glance, we can see that the device health is lower because of disk space issues and memory issues. We get an inventory of the devices that make up this cluster, in which we have two cluster pairs, both virtual editions, running 1151, with 01 being active. We have a list and inventory of diagnostics coming back from iHealth. Let's go ahead and investigate this disk space health issue. Go to the disk statistics page, and we can quickly at a glance view which partition has space issues. It looks like varlog is completely full. We can also see this from a disk usage mount point perspective. In addition, we can see our latency statistics. It also looked like we had some system performance issues with memory. We go to the System Performance tab and look at the performance from a memory perspective on the two devices within this device service cluster. Here we can see that the memory utilization for 01 and for 02 is hovering around 99% utilized. We also see this CPU spike that's occurred over the last several hours. We can highlight this spike to understand what processes are utilizing a majority of the CPU. Here we can see a breakdown of the device service cluster based on module and based on process. Here we see a clear indication that the learning process from ASM and the MySQL process that goes along with the learning message process is utilizing a high percentage of the CPU. Lastly, we can look at different events going on for this big IP. Here we can see a breakdown by category of the different events going on. By clicking on a specific message, we can actually filter out the events based on that category and time.
Hey, it looks like something happened to my application this afternoon. We have not done any work on the application or the servers at all today, but we've been getting a lot of complaints from users. Can you have a look at the F5 environment and make sure that it's healthy?
Sure. Happy to have a look. We just installed this new Splunk app from F5, which should help make this a lot easier. Let's start to investigate the issue by starting with the application dashboard page. This page will allow us to see a list of all the different tenants and applications running. We can filter this based on the tenant that we had complaints for. We We know that was for company.com. Here we have a list of all the different apps for that tenant. And we know that the application name was blog.company.com. We can look at a glance to see if there's any glaring issues based on this expansion, in which we don't see too many, others some random TCP errors. We can go ahead and drill into the application and investigate further. Within the overview page of the application drill down, we can see that there might be some server latency issues as well as some response code issues, but nothing glaring in regards to an application fully being broken. If we scroll down, it looks like there's some iHealth diagnostic data related to the big IPs that this is running on, but nothing glaring as well. Let's take a look at how the application is actually deployed on the Applications Resources tab. Here we can see that there's two different virtual servers deployed for this application. One within New York City, one within San Francisco, as well as a wide IP that is distributing traffic to both. Looks like all the pool members are online, as well as the virtual servers. Let's have a look at the client view of the big IP. Here we can see that throughput looks to be normal for the two different facilities, as well as that there are no glaring TCP errors going on. So that can't be it either. Let's go ahead and take a look at the different events and alerts that might be going on for this application. Here we can see that we have some TCL errors occurring from an iRole perspective. We can go ahead and filter down to a specific time and category and investigate these logs in more detail. Here we can see that we're getting a divide by zero error while executing part of the iRole. We can also see that these events started to happen right around the time of this audit message. Let's go ahead and click on that specific time and category. We can quickly see that there's a specific user that logged in and added this new iRole blog to the virtual server in question. This would indicate that a user created this issue for this application. The course of action would be to remove the iRole or correct the iRole statement causing the divide by zero error.
Thanks for looking into that issue yesterday and fixing it. The app has been running smoothly until today around lunch. Wanted to see if you could help me track down a latency issue.
Actually, that's something you can do yourself. With the new F5 Splunk app, you should be able to log in, see the applications that you have control over, and view the performance and statistics for that application. You should be able to quickly track down that latency issue.
Thanks. I didn't know I could go have a look myself. Could you walk me through it so I can do this in the future on my own?
Sure thing. Let's first start by having you log into Splunk. Here you can see a quick overview of your environment. It looks like you have one application that you have access to. You can see here from a health score index that it's looking like it's not performing well. In addition, it looks like you have some recent pool members that went down. Let's go ahead and click on the application and look at it further. Looking at the application drill down page, we can see that it does look like you have some server latency issues occurring. Let's look to see how this application is actually deployed on the F5s. We'll go to the Applications Resources tab, and here you can see you have visibility into the F5's configuration. You can understand that we have two virtual servers in each facility for your application, and it does look like those three pool members are offline for that specific pool in SFO. Let's go ahead and take a look at that application latency issue. On the Application Latency and Analytics tab, we can scroll down to see the latency based on any of these different dimensions. Right now we're looking at it based on facility. We can see that it looks like you have a high percentage of latency occurring within the SFO facility. And it does look like there are a couple key pool members that have been called out in regards to that latency. Let's look at that by clicking on the filter. Here we can see for the SFO facility that it looks like for the home page we have high latency for those specific servers. Let's look at the security of the application. It looks like you're seeing several different types of attacks coming in and being mitigated by the F5 technology. Here you see that AFM is mitigating using sweep flood protection, as well as protecting against a TCP SYN-ACK flood. We can see also that ASM is protecting against a layer 7 attack using client-side integrity defense. At the application level, we can see that there are some attacks that are being mitigated as well. It looks like we have some attacks going against both virtual servers that make up this application, specifically attacks that are common from a signature perspective, as well as an attacker that is trying to evade these attacks. We can see those log messages in more detail over time, looking at the events and alerts that are occurring. We can click on any one of these given moments in time. We can look at the exact events occurring based on the time and category.